Hello, 7th graders. In this video, I'm going to demonstrate how to use different types of simple machines. What you need in this activity are the following: your worksheet on simple machines and your pencil if you're using the paper copy, or the online document of this, online version of this if you're answering online. All right, so we're we're not only gonna use the machine, but we're also gonna record data of the force that we have to apply with and without the machine. So we're gonna start first with uh, what force do we have to apply uh, without the machine. So we're gonna use this scale, which is calibrated already to 0, and this is gonna be our weight. Okay, so what's gonna happen is I'm gonna lift this weight and I will measure the force that I have to exert without the assistance of any machine. Okay, so as you can see, I'm lifting this up already, and this is the measurement of the force. So you will see that it's around 4 Newton. Okay, so that's the force that you have to exert to lift this object without the machine, and you're gonna record it here in the beginning of station 2, beginning of station 3, and beginning of station 4. Again, the measurement is 4 newtons. Okay. All right, now we're gonna start with station 1, which is an inclined plane. So this is how inclined plane look like. All right, so you have the plane or the ramp, and the books will serve as the one that's makes the height different. So what we're gonna do is we're gonna lift this object up this way. So a while ago we lifted it this way, and now we're gonna lift it this way using this machine, and we're gonna measure the force that we have to exert at different height. So we have 4 books, 3 books height, and 2 books height. So we're gonna start with 4 books. We'll measure first the height of the 4 books, and it's 14 centimeters. So you're gonna record that right here. Okay, and then we'll measure the force we're gonna need to lift this up. So the force is 2.5 Newton. Okay, now we're gonna go to 3 books. So we're gonna remove 1 book, and we'll measure the height again. So this is 10.5 centimeters. And then for the force, okay, it's about 2.4 Newton. And then finally, 2 books remaining. The height of 2 books is 7 centimeters. And then the force that we need to exert just 2 Newton. All right, after this, you're going to answer the questions. The questions are, what happens to the amount of force needed as the height of inclined plane decreases? So you will notice that from 4 books to 2 books, the height is decreasing. What can you say about the force that you have to exert? Is it increasing or decreasing? Question number 2, how would you use the inclined plane to lift the weight with the least force? So if you're gonna be asked to choose the type of machine, and you want the machine to do the work for you, meaning you have to exert least force, would you prefer the higher height or the lower height? Again, your goal here is you're gonna exert lesser force. Question number 3, how did the force required to lift the weight without the machine compare to the force needed with the machine? So compare the amount of force that you have to exert without the machine, this is 4 Newton, compared to with the machine. Which one is greater? Without the machine or with the machine? So which one is easier to do? Without the machine or with the machine? So that's for the questions 1 to 3. So we're now gonna move on to uh, the next station, which is the lever. So this is the lever. It has also the plane and the fulcrum. All right. So what we're gonna investigate is how much force is needed to lift the object from this point if we will push a force in here. So what force do we need to lift the object like that? All right. So we have a different distances of the weight from the fulcrum. So we have 15 centimeters, 20 centimeters, and 30 centimeters. So we're going to start with 15. So this is 15 centimeters. Okay. All right. So our weight is right here. And then I'm going to make sure that it's still calibrated. And then we're going to measure the force. So the force for 15 centimeters is 0.5 Newton. So again, that's 0.5. All right. Now, next one is 20 centimeters. So that's 20. Okay, so you can see it. Okay, so it's 1.25, around 1.25 Newton. Okay, next one would be 30 centimeters. So this is 30 centimeters. So if you will notice, the amount of force that we have to exert exceeded the amount of force we have to exert by lifting it without the machine. So 4.6. All right. So which means if the distance of the object or the weight is too far from the fulcrum, it's as good as not using the machine, or it's better not to use it at all. I mean, you're exerting more effort. Unlike when it's closer, you're exerting less effort. Okay? So let's answer the questions now. Question number 4. What happens to the amount of force needed as the distance between the weight and the fulcrum increases? So when the distance of the fulcrum gets farther from the weight, is the force increasing or decreasing? So you're gonna look from 15 to 30. Is it increasing or decreasing? Is it getting easier or harder? Okay, question number 5. How would you use the lever to lift the weight with the least force? Okay, so just like in the previous station, would you rather have the weight to be closer to the fulcrum or to be farther from the fulcrum? So again, this is the fulcrum right here. And then question number 6, how did the force required uh, lift the weight without the machine compared to the force needed with the machine? So this one, it depends, because if the weight is closer to the fulcrum, then compare the amount of force here to here. But if it's farther from the fulcrum, look at the force with the machine without the machine. All right, so we're now gonna move on to station 3. So station 3 is a wheel and axle. Station 3 is wheel and axle. So the wheel is this one, and the axle, let me just show it this to you, is this one. So it's attached to the wheel. So the weight is dependent on the axle, and the axle will move when the wheel moves. Okay, so the force is applied to the wheel, and the axle is the one that is carrying and gonna move the weight. All right, so let me just show you the structure closely. And then we have a pen right here where we attach the axle. All right, so what we're gonna do is we're going to lift the weight 5 centimeters up. Okay, so let's measure right now. It's as this high. So let's just mark this with a pencil. And we have to raise it 5 centimeters up. So at this height. So we're going to measure the force that we have to exert it using this scale. And then later on, we will measure the distance that we have used with the string. So let me just position it this way. Okay, so I'm going to pull it now. All right, so in my measurement, I'm using a zero point 0.5 of force or tensional force, and the distance of the string that I have to use is uh, 26 centimeters. So let's record that. I use zero point 0.5 amount of force, and 26 centimeters is the length of the string. So if you will compare the radius or the circumference of or the total string that the axle used. So let me just show it to you. This one, the one that circulate on this axle to lift up the weight, is 5 centimeters, and the string for the wheel is 26. So that's the ratio of the axle and the wheel. All right, and this is the force that you have to apply. So to answer the question number 7, how did the distance you pulled the string compare to how high you lifted the weight. So what you will compare is this 5 centimeter and 26. So how big or how long is the string for the wheel compared to the string on the axle? Okay? And question number 8, how did the force required to lift the weight without the machine compare with the force needed with the machine? So you will compare these two. Which one is bigger, without or with the machine? All right? So we're now going to move on to station number 4, and this is the final station. All right, so we're already on station number 4, and you call this machine a pulley. So this is the pulley. It's like a wheel which is attached to the string. So our weight is on the other side, and the force that we have to apply is downward while it moves upward, uh, and that is where we're gonna measure the force. Okay, so I'm gonna position this first, and I will measure the force that I need to lift this up. So right now, I'm exerting 4 newtons of force, which means it's as good as no machine because I also exerted 4 newtons of force. If there's a difference, it might be just zero point 0.1, okay? But we're going to record 4 newton. So 4 newton of force, and that is with one pulley, meaning we only have one of these. So on the second part, we're going to have a double pulley wherein we're going to attach the other pulley on it. So I'm just going to construct it first. So to understand how the single and double pulley differ from one another, so this is the single pulley. That's what I did a while ago, and this is gonna be what we will construct with the double pulley. And here it is. Here's your double pulley. So the string is that I'm exerting force to is connected to the first pulley and surrounding the other pulley. So this pulley is being brought up. That is making this weight go up as well, while this pulley is being pulled down. Okay, so the force is coming from this. It's being pulled down, and this is being pulled up, and that is what's lifting our object. So let's measure the force that we have to exert with having two pulley pulling the weight. So in my measurement, I'm only exerting 2 newtons of force in order to lift it up. So it's a lot easier than compared to having just one pulley. All right. So that is our data. Okay, now question number 9, compare the force needed to lift the weight with a single pulley to double pulley. So compare in which pulleys will you exert lesser force, the one with single or the one with double pulley. And then question number 10, how did the force required to lift the weight without the machine compared to the force needed with the machine? So compare it with single and double pulley. So for single, it's just the same, but for double pulley, it's a lot easier with double pulley. And those are all the simple machines. Again, inclined plane, lever, wheel and axle, and your pulley. So I hope that you were able to record all your data and answer the questions. If you have any more questions about simple machines or how to complete this project, just send me a comment in the Google Classroom or email. Thank you.